Right, Hannah? So we'll start today with equilibrium. So is it audible clearly, right? Hello. So how many of you know equilibrium? So equilibrium. Hmm? Right, right. In equilibrium, we'll had two types: chemical equilibrium, ionic equilibrium. What is exactly the equilibrium? Equilibrium means what? Balancing, right? So generally, reactants are converting into products and products are converting into reactant. Okay? Reactant converting into products, products are converting into, this is called a reversible reaction. Reversible means, so when reactant and product are coming, so both are in the equilibrium, so that we could say the equilibrium. So generally reactions are two types, right? Reversible reactions, irreversible reactions. Irreversible means what? Only one direction. Reaction is converting into product, but product cannot convert into reactant. Any examples for irreversible? Irreversible. For example, if you are burning a paper, can it take it back? No, right? Right. Now, so actually, in the total physical equilibrium is there, chemical equilibrium, ionic equilibrium. So, a lot of equilibriums are there. We'll discuss classification of equilibrium. For example, N2 plus 3H2 gives rise to 2NH3. Okay. For example, CH3 COOH gives rise to CH3 COOH COO minus H plus. Both are equilibrium. So what is the difference here? Both are equilibrium, reversible reactions. Reversible means reactant is converting into product, as the same time product is converting into reactant. In this case also reactant is converting into product, so product is converting into reactant. So what is the main difference? In this case, ions are forming, right? Hello. Ions, anion like cation, and right, ions. When ions are forming, those equilibrium we will study in terms of what, Nana? Ionic equilibrium. So in this case, no ions are forming. The reactant N2 plus 3H2 gives rise to 2NH3. This will be, here we will discussing chemical equilibrium. So equilibrium we are just broadly dividing into two equal halves: chemical equilibrium, ionic equilibrium. Okay. In chemical equilibrium, what we will do? So first we will do the classification. So how many types of homogeneous equilibrium, heterogeneous equilibrium means if all are in the same phase. First, reversible, irreversible, dynamic, static, physical equilibrium, chemical equilibrium, right? So lots of equations are there. Then we'll discuss what exactly Kc, Kp, Kc, Kp relationship, So majorly the problems they are asking from KCKP and Lee Chatelier principle. Lee Chatelier principle. So these things generally we will discuss in chemical equilibrium. So then in case of ionic equilibrium, we'll discuss acids, right, bases, strong acids, weak acids, strong bases, weak bases, right, salts, and pH calculations, pOH calculations for different strong acids, mixture of strong acids, weak acids, mixture of weak acids, mixture of strong acid and weak acid, mixture of weak acids, weak base, strong base, mixture of strong bases, mixture of weak bases, mixture of strong and weak bases. So a lot of things we will discuss in the pH cases. And solubility product and salt hydrolysis. Salt hydrolysis, different types of salts are there. Salt of strong acid, strong base, weak acid, weak base, strong acid, weak base, weak strong base, weak acid, like that. So we have, and buffer solutions. Buffer solutions. Buffer solutions means what? When we are adding some small amount of acid or base, there is no change in the pH. So those buffer solutions and solubility product. Last I told you, right? Solubility product. So lots of things we will discuss in chemical equilibrium and ionic equilibrium. Okay. So is it clear? Right, Nana? So is it audible, right? Yeah. Right. So put the heading equilibrium. So what we can see here particularly, what it seems to be balancing, right? Balancing. Both are in the same. Right, Nana? So equilibrium generally static equilibrium, dynamic equilibrium. So static means what? Dynamic means. Anyone? Dynamic equilibrium, static equilibrium. So particularly static means, for example, try to understand, Nana. Reactant is converting into product, okay, and there is no equilibrium. Imagine reactant is converting into product and product is converting into reactant. It is reactant, for example, concentration is 10. So 5 moles, imagine 5 moles of converting into product. At the same time 5 moles are converting into reactant. Imagine, right, it is 10 moles are there, it is 20 moles are there. 10 becomes 5. So immediately the 5 is coming from the back side. So 10 goes to 5 means 5 is remaining, right? Immediately the 5 is coming back. This process keep on undergoing, but there is no change in the concentration of 10 and 20. It seems to be dynamic, right? Dynamic means what? Reactant is converting into product, product is converting into reactant, continuously takes place, but it seems to be no change. Whereas in case of static case, so there is no exchange of reactant to convert into product and product is converting to reactant. For example, imagine it is 20, 10 or 20, but there is no exchange. Got it? Hello? Dynamic equilibrium means ante reactant product avutadi, product reactant avutadi, continuous ga jaruguta untadi. Okay. Static lo enti reactant product avutadi, product ante kaavu, aagipotadi reaction. So for example, try to understand. ఇక్కడ నేను ఒక ఐస్ తీసుకున్నాను రా. ఇక్కడ ఐస్ అనేది ఫ్లోటింగ్ ఉంటుంది కదా. హలో, ఇది వాటర్. సో ఇమాజిన్ dynamic case 10 water molecules are converting into liquid and at the same time 10 is converting into ice. The process is keep on taking place, but there is no change in the ice and water. This is we are called as what? Dynamic. అంటే వాటర్ ఐస్ అవుతుంది, ఐస్ వాటర్ అవుతుంది, డైనమిక్గా అవుతుంది. బట్ ఇన్ కేస్ ఆఫ్ స్టాటిక్ కేసెస్ ఏమవుతుంది? సేమ్ ఇంతే ఉంటుంది, ఐస్ అనేది వాటర్ అవ్వదు, వాటర్ ఐస్ అవ్వదు, బట్ అలా ఉండిపోతుంది. సో దాన్ని స్టాటిక్ అంటాం. నన్ను కాబట్టి హలో రైట్. టైప్స్ ఆఫ్ ఈక్విలిబ్రియం. సో స్టాటిక్ అండ్ డైనమిక్. I told you in this type of equilibrium, what happens? The system at rest, no actual change happening, either macroscopic level also and macroscopic and microscopic levels. This dynamic equilibrium can be happened the state which rate of movement forward and backward reactions, right, is equal and no net changes takes place. Got it everyone? Static and dynamic case. Any doubt? Hello? అర్థమైందా? సో స్టాటిక్ ఈక్విలిబ్రియం అంటే ఏంటి? అంటే రియాక్టెంట్ ప్రొడక్ట్స్ చేంజ్ ఏమి ఉండదు. డైనమిక్లో ఏమవుతుంది? రియాక్టెంట్స్ ప్రొడక్ట్స్ అవుతాయి, ప్రొడక్ట్స్ రియాక్టెంట్స్ కూడా అవుతాయి, బట్ అక్కడ చేంజ్ ఏం కనపడదు, మళ్ళీ మనకి డైనమిక్గా ఉంటుందని. ఓకే, సో జస్ట్ రైట్ ఇట్ డౌన్ దట్. హలో సార్, క్లాస్ స్టార్ట్ అయిందిగా. 8 o'clock రమ్మని అయితే ఉంటాను ఇక్కడే. నాన్న ఇతర నువ్వు ఆన్లైన్లో వస్తున్నావు ఈరోజు? రైట్. సో టైప్స్ ఆఫ్ కెమికల్ రియాక్షన్స్: irreversible, reversible. I already told you. So what is the major difference? Let me know. What is the major difference between reversible reactions and irreversible reactions? Board కనిపిస్తుందా క్లియర్గా? Yeah. So I told you, in case of irreversible reactions, what reactant is converting into reactant is converting into product, but product is cannot be converting into reactant. Reversible reactions, what happens? Reactants converting into products. Product can also converting into reactant. So we'll show this arrow. In this case, double arrow, of course. Yes or no? Okay, na? So this irreversible reactions takes place in open vessel. Yes or no? Open vessel. Reversible reactions takes place in what? Closed vessel. In this case, limiting reagent. We cannot apply the limiting reagent over here. So what is the limiting reagent? How many of you know? Limiting reagent. We can apply the limiting reagent over here, but we cannot apply the limiting reagent in this case. What is limiting reagent? Anyone? For example, N2 plus 3H2 gives rise to 2NH3. I'm just taking 10 moles of nitrogen, 10 moles of hydrogen. How many moles of ammonia forming? What is limiting reagent here? What is limiting reagent here? What is limiting reagent? What is limiting reagent? Nitrogen or hydrogen? Hello? Anyone? So 1 mole ki 3 moles, 10 mole ki 30 moles తీసుకోవాలి, but నేను 10 moles తీసుకున్నాను. The reaction which is 100%, the reaction which consumes 100%, right? That is limiting reagent. In this case, hydrogen is limiting reagent. Yes or no? Yes or no? Otherwise, we can say 10 by 1, 10 by 3. It is 10, in this case 3.33. So which is 3.33 nothing but which is coming in the less, that is called limiting reagent. That means which consumes in the 100%. ఒక మోల్కి 3 moles తీసుకోవాలి, 10 molesకి 30 moles తీసుకోవాలి, బట్ మనం ఎన్ని మోల్స్ తీసుకుని 10 తీసుకున్నాం. ఇట్స్ కాల్డ్ లిమిటింగ్ రియేజెంట్, రైట్? సో లిమిటింగ్ రియేజెంట్ ఈజ్ అప్లికబుల్ ఓవర్ హియర్ బట్ నాట్ ఇన్ దిస్ కేస్. Okay, so we'll discuss one by one points here. Reversible, irreversible cases, nana. So reactions will proceed one direction only, means reactant is converting into product. Reactants almost all completely converting into products. Products do not react with form the reactant again, means backward reactions won't take place. Do not attain equilibrium state, right? Represented by single arrow. So just write these points. Come on, write these points. 1, 2, 3, 4. Example for irreversible reactions, give me some examples. Along with this, I gave you one nitrogen. Write it down. All combustion reactions. All combustion reactions. All combustion reactions. All combustion reactions. Precipitation reactions. Precipitation reactions. And reaction between strong acid and strong base. Reaction between strong acid and strong base. Also irreversible reactions. Got it? Hello? And it involves limiting reagent and raskone. One more point. It involves limiting reagent. limiting reagent. It involves limiting reagent. And one more important point, takes place in open container. Write one more point. Takes place in open container. Open container. These are all irreversible reactions. So all combustion reactions, all precipitation reactions, and reaction between strong acid and strong base. This is also very important. Reaction between strong acid and strong base. Okay. Then completely shall I move? Hello. Completed. So precipitation reactions, so write one example, and for neutralization reaction, write one more example. These are all irreversible reactions. Precipitation reactions, neutralization reactions, I told you, and one more combustion reaction, right? Then NaCl plus AgNO3. AgCl is, and AgCl is precipitator. Then hello, completed. Next, irreversible reactions. Reversible. Reversible case reactions proceed in both directions. I told you. Reactant is converting into product and product is converting into reactant. Reaction never goes completion. So in case of a reversible, reaction will be completed. Products react, right? Products reacts to form reactants again, means reactant is converting into product and products can back the reactant is forming. Attains equilibrium state. So H2 plus I2 gives rise to 2HI. And one more important point, it takes place in closed vessel. Write it down along with these points. First write these points along with, because each and every point is important in chemistry. So earlier only important areas they are asking the question, but recent JEE and NEET questions last time also. So each and every point, which of the following statement is true, which of the following statement is right. So each and every point is important. So try to write each and every important point. Got it? That's the reason to without missing. So I'm just giving the PPT. Got it? So they are asking the statement, which of the following statement is correct, false, like that. For irreversible or reversible reactions, which of the following statement is false, like that they are asking. For example, which of the following statement is false? In this case, limiting reagent is applicable. Can we apply the limiting reagent here? No, we can't apply the limiting reagent. So reactions are takes place in closed vessel. Write it down one more point. Closed vessel. Write it down these examples. First write the points. 1, 2, 3, 4. No role of limiting reagent. No role of limiting reagent. No role of limiting reagent. Then, did you write the points? Hello? Right now? Meghana రాసుకుంటున్నావు? Okay. So point mistake and if possible take the screenshot, okay? Write these two examples also. N2 plus O2 gives rise to 2NO. PCl5 gives rise to PCl3 plus Cl2. This example also we can use more and more. N2 plus 3H2 gives rise to 2NH3. N2 plus 3H2 gives rise to 2NH3. Done, Anna. Write bit fast. So here is two types of equilibriums. One more type. Homogeneous, heterogeneous. Anyone? What is homogeneous and what is heterogeneous? Neeraja? Same state, same phase. And all are in the gases, all are in the liquid, all are in like that. Heterogeneous means one solid, one liquid, one gas like that, right? Right. Homogeneous, all are reactants, products are in the same phase. For example, see ethyl alcohol and ethyl, right? Acetic acid or ethanoic acid, we can say. Ester is forming plus H2O. All are in the liquid state, homogeneous. All are in the gaseous state. Write the examples. Homogeneous, all reactants and products. All reactants and products are in the same phase. All reactants and products are in the same phase. మొబైల్లో చూడకండి సో ల్యాప్టాప్లో చూడడానికి ట్రై చేయండి ఓకే మొబైల్ అయితే చిన్నగా వస్తుంది కదా కంప్లీటెడా హలో heterogeneous means reactants and products are more than one phase with different phases. It is solid gas like that. Solid gas, right? Solid gas, but different phase, right? It is diamond is different phase, like of course both are solids but different phases. Diamond and graphite. Write the examples. Then right now. Once it's done, please let me know done. Anyone? Next, one more equilibrium, physical equilibrium, chemical equilibrium. Write it down. Classification, we are doing the classification, physical equilibrium, chemical equilibrium. What is the difference between physical equilibrium and chemical equilibrium? Anyone? Anyone? Physical equilibrium and chemical equilibrium. In this case, physical change only means there is no change in the chemical formula. H2O will become H2O, solid becomes liquid, liquid becomes solids, like that equilibrium is establishing. Chemical equilibrium, so N2 plus 3H2 gives rise to like that. So we'll discuss here. Right, phase transformation, in this case sublimation. For example, solid, liquid, right, melting. So on evaporation it becomes gas. On condensation becomes liquid, and freezing it becomes solid once again. From solid to directly gas means what? Sublimation. Okay. So gas to directly solid, deposition. Just write it down, this process. Melting, evaporation, condensation, freezing. Phase transformation process. Solid converting into liquid means melting. Then sublimation means what? What is sublimation? Solid to gas. Write it down. Then next. Right. Physical equilibrium means what? Equilibrium in physical process, solid to liquid. So physical equilibrium, liquid to vapor or solid to vapor or anything is possible, right? Dissolution of gases in the liquid, but there is no change in the chemical formula. No? Anything we can say. Just one example is enough. For example, we can use H2O, solid. Equilibrium is H2O, liquid. Now. So this we can say, because there is no change in the formula, right? Phase, solid converting into liquid and liquid converting into solid, this we are called as what? Physical equilibrium. One example is enough. Right. Chemical equilibrium means, right, equilibrium in a chemical process, right? For example, N2 plus 3H2, I already told you. So reactant is converting into product. So I'll discuss rate of forward reaction and rate of backward reaction. So balancing each other. For example, I will take the same example, N2 plus 3H2 gives rise to 2NH3. At time t is equals to 0. So here is concentration CC 0. products. So just write chemical equilibrium, physical equilibrium and chemical equilibrium. So here is no that much of, they are not asking much more here. So rate of forward and backward, so I'll discuss that, no issues, no need to write here. Right, Nana? So graphical representation, in this graphical representation is very important, Nana. So we'll do one thing. So write the question, which of the following represents equilibrium? Which of the following represents equilibrium? So here is, write it down, rate, rate, rate. So rate versus, so we can go with time, Nana. Rate versus time. Write these three graphs, write along with me. Write these three graphs now. So this is RF now, forward reaction, this is backward reaction. Forward, backward. RF. Yeah. So which represents equilibrium? Which graph is represents equilibrium? One more important question. Right here is concentration. Concentration. This is A, this is B, this is C. This is also A, B, C. This is a question number 1, this is question number 2. Write the two graphs. Write two graphs. And which represents, in first question, which represents equilibrium? In second question also, which represents equilibrium? First question same. Okay. So your first question is C, second question is B. Any other answers? Hmm? First one is second one is remaining guys. Neeraja. Right or wrong doesn't matter when I'm asking. So let me know. Hmm? Which one? Yes. So in this case, Nana, first case, So rate of forward reaction and rate of backward reaction both should be equal. C is the right answer. So rate of forward and rate of backward should be equal. But whereas in case of concentration, it could be anything, no issues. All are correct. Anything we can say equilibrium. Okay, concentration doesn't matter, only rate is the matter. So rate of forward and rate of backward should be equal, but not the concentrations. Okay, write it down. For example, concentrations ఈక్వల్ ఉండాల్సిన అవసరం లేదు. అంశని అర్థమైందా? ఎందుకంటే ఫర్ ఎగ్జాంపుల్ రేట్ ఆఫ్ ఫార్వర్డ్ అండ్ బ్యాక్వర్డ్ రియాక్షన్. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ వీడి దగ్గర 1000 రూపాయలు ఉన్నాయి ఫస్ట్ వన్ దగ్గర, వీడి దగ్గర 200 ఉన్నాయి అనుకుందాం. ఓకే, వీళ్ళిద్దరు ఈక్విలిబ్రియంలో ఉంటారా ఉండరా? ఉండొచ్చు. ఇప్పుడు వీడు 100 రూపీస్ వీడికి ఇచ్చింది అనుకోరా, వీడు 100 రూపీస్ వీడికి ఇస్తే అర్థమవుతుందా? వీడు 100 ఇస్తున్నాడు, వీడు కూడా 100 ఇస్తున్నాడు. వీడి దగ్గర ఎంత ఉన్నాయి, వీడి దగ్గర ఎంత ఉన్నాయి మాకు సంబంధం లేదు. అర్థమవుతుందా? కాన్సన్ట్రేషన్ డజంట్ మ్యాటర్, బట్ rate is important. So A, B, C 3 are correct. All important, no? A number of times they are asking the question based on this. Right. So here is rate of forward, rate of backward reaction. Concentration, it could be anything. So one graph is given as, yeah. Previous slide. Okay. Done. So concentration case, these 3 are correct. I gave you, right? So for rate case, equilibrium is only this one, rate of forward and rate of backward, when rate versus time, right? When concentration versus time, this is correct. Okay, and I already gave you, so this one and this one. Three graphs. Okay, done. Right. So no change in the concentration either in the reactants or products. When reactant molecules continue to form the products, vice versa. Reactant is converting into product and product is converting to reactants. So already it is in the equilibrium, there is no change. Okay, write this example. N2 plus 3H2 gives rise to 2NH3. Done. So equilibrium mixture, reactants and convert, of course, this is called after attaining the equilibrium. reactants and converting into, this is equilibrium mixture, so no need to write, let it be. So essential conditions, I already told you, reversible reaction, hello, I told you, right? Hello, which container should be present? Closed container. I already gave you this point, no issue. So at equilibrium, all macroscopic properties such as pressure, concentration, right, density and color, right, of the system appears to be constant at equilibrium. After attaining the equilibrium, write that point. At equilibrium or after attaining the equilibrium, all macroscopic properties, after attaining the equilibrium, all macroscopic properties such as pressure, concentration, right, density, color will be constant. They'll ask the question like this way: after attaining the equilibrium, which of the following will change? Which of the following will change? Right, some more, Nana, along with this, right? Pressure tarvata volume also. Volume, concentration, already I told you, right? Temperature, you can write the temperature. Volume, temperature, pressure, concentration, density, color, mass, mass, moles also, all are constant. Then, hello, Rasarara, important point. After attaining the equilibrium, so they'll ask CaCO3 CaO plus CO2. So ఇదేం అవసరం లేదు. After attaining the equilibrium, right? Extent of reaction. What's this? So characteristics of a chemical equilibrium. So here is one to one, write it down. Equilibrium is dynamic in nature, already we know. Dynamic in nature means reactant is converting into product and product is converting into reactant. Second, equilibrium involving the gas is established in the closed system. Obviously, equilibrium system is unaffected by the catalyst, but it attains the faster and slower depend upon the catalyst type. No. System moves at equilibrium state spontaneously. Write each and every point. Characteristics of equilibrium. So put a note heading and write all points. After attaining the equilibrium, there is no role of the catalyst. Actually, catalyst ఏం చేస్తుంది, ఈక్విలిబ్రియం తొందరగా అవ్వడానికి హెల్ప్ చేస్తుంది. Okay, write the points. Equilibrium is dynamic in nature, already we know. Equilibrium involving the gases, right? Gas is established in the closed system. If it is in the open system, the gas will escape, right? That's why already I told you, reversible process. Equilibrium stored unaffected by the catalyst. And last one is system moves to an equilibrium, it is spontaneously. What is spontaneously means? What? without making any efforts. Delta G is equals to negative nano. Completed? So, each point is important, so don't ignore. So we don't know where they are asking the questions. అసలు ఇంపార్టెంట్ కానీ కూడా అడుగుతున్నారు. ఇంతకుముందు ఏంటంటే డైరెక్ట్ ఫార్ములా బేస్డ్ అవే చెప్పుకుంటూ వెళ్ళిపోయేటోళ్ళం. డైరెక్ట్గా నేను కేసీకేపీ రిలేషన్షిప్ చెప్పేసి లిచాట్లియర్ ప్రిన్సిపల్ చెప్తే అయిపోతుండే. గిబ్స్ ఫ్రీ ఎనర్జీ, థర్మోడైనమిక్స్ ఆ మూడు చెప్తే అయిపోతుండే. బట్ సో దట్ ఈస్ నాట్ ఎనఫ్. రైట్, వన్ మోర్ పాయింట్ రా. So rate of forward reaction is equals to rate of backward reaction. Already I saw you, right, we saw in the graph, right? Next, at equilibrium, the concentration of the reactants and products becomes constant. I already told you this concentration. This is important. Equilibrium can be achieved from both directions. So both directions means what? Imagine here is, for example, reactant is raised to products. No? Here is somewhat A concentration is 0. So means now in this case equilibrium is established, right, by the forward direction. Like this also happening. Already we are taking the some concentration, reactant concentration is 0. So means backward side also it's happening, right? Equilibrium can be achieved from the both direction, either forward as well as backward. At equilibrium, free energy change delta G is equals to 0. After attaining the equilibrium, delta G is equals to 0. Write that points. 7 points which I am giving you. లాస్ట్ టైం నీట్లో కూడా అంతేనా, కొంచెం ఇంపార్టెంట్ అనుకునే కూడా ఇవ్వలేదు క్వశ్చన్స్. సోనా నువ్వు వింటున్నావా? సోనా అంతేనా? కంప్లీటెడ్. I already told you it should be any either directions, forward direction or backward direction. Imagine, right, in this case, late after 75 conversion of the equilibrium achieves. Concentration, initial concentration Ci 0.2, 0.6, the product is 0. At equilibrium, concentration at equilibrium, this is becomes 0.05, this becomes 0.15, but this is 0.3. So means in this case equilibrium achieved by the forward direction. So actually no need to write, okay? If you want you can write it down, but no need to write. And the equilibrium state can be achieved from the product side also. In this case what exactly happens? I already told you is the product's case initial concentration case 0.4, but reactant concentration what now? Hello, 0. After equilibrium what exactly happens? The same thing is happened. And try to understand the concentrations after attaining the equilibrium either forward and backward. So C is 0.05, 0.15, 0.3, whereas in this case, same, right? Hello. After attaining the equilibrium, the concentrations are constant, 0.05, 0.15. In this case also 0.05, 0.15. Okay, now? So what is this points indicates us? The equilibrium can attain both the directions, either forward direction as well as backward direction. Let after 50% conversion of the equilibrium, it is 0.3, 0.60. So after equilibrium, Nana, this composition cannot be starting from backward reaction simply. Okay, so no issues. That is total forward and backward. It can be. Next, Nana, law of mass action. This is important. For second year, guys, in chemical kinetics also it's coming once again. At rate equation case, I'll explain this. What is law of mass action? Rate of chemical reactions proportional to product and active masses of the reactant raised by its stoichiometric coefficients. Nana. Simply, I'll tell like this. Imagine, for example, AA plus BB gives rise to CC plus DD, Nana. Okay? Hello. This is the equation. According to law of mass action, rate is directly proportional to concentration of, in this case, reactants. Reactants will take, okay? Concentration. This is main, this is coefficient. So A power A and B power B. This is where called as law of mass action. For example, N2 plus 3H2 gives rise to products. Products means 2NH3, of course. How can we write law of mass action? Tell me. Rate is directly proportional to reactants. We'll write N2, concentration of N2 and concentration of H2 power 3. Whatever the coefficients are there, those we need to write in the square. Okay, so just write this. Completed? Each and every point is important. So product of active masses. What is active masses of reactants raised to the power of their stoichiometric coefficients? So if you want, you can write it down. For example, AA plus BB gives rise to products. So rate is equals to, I told you, are directly proportional to A power A and B power B. So in this case, the brackets, square brackets I am writing, right? Hello. For A, I am writing the square bracket like this. Yes or no? Hello. The square bracket is nothing but active mass, Nana. Nothing but what? What is this? Active mass. What is active mass? Active mass nothing but what? What, Nana? Concentration. Concentration is nothing but N by V we will take. N by V. Concentration like molarity, right? Number of moles by volume like that. Active mass nothing but what? concentration. So we'll say rate is directly proportional to concentration, A power A. I'm just taking a concentration power. Concentration terms we will write like the square brackets. Got it? Active masses of reactants raised powers of their stoichiometric coefficient. What are the stoichiometric coefficients? This small a is the stoichiometric coefficient, small v is the stoichiometric coefficient. Got it? Hello? So same example which I gave you over there, right? So same, Nana. Rate is directly proportional to what? N2 and H2 power 3. Stoichiometric coefficient over 3. We have to write the 3, right, on the powers. Got it? Clear? So it is explained by Goldberg and Wage. What is active mass? Hello? What is active mass? Active mass nothing but what? Concentration. So effective amount of reacting species taking place in the reaction row. So generally active masses I told you, right? Molarity, partial pressures. Molarity and partial pressures. So for if the gases is there, we'll take the partial pressures. If any concentration is there, we'll take molarity. Okay, na? So no need, that already I told you the active masses. So no need to write this. So active masses for pure liquids and solids equals to 1. So write this point is very important. So write it down. Active masses of pure liquids and solids is equals to, because concentration is constant, right? Pure cases. Or solids and liquids, moles by volume, moles, mass. So what is moles, Nana? Nothing but concentration, right? Hello? Concentration, nothing but what? Molarity. Moles per volume. Moles means weight by molecular weight. Weight or mass by molecular weight into volume. So something mass upon mass were called as density into molar mass. Density, mass upon volume, nothing but density, right? So generally మనం molarity ఏం రాస్తాం bro? N by V. Yes or no? N is nothing but what? Weight by molecular weight into 1 by V. So weight by volume is nothing but what? Hello? Density by molecular weight. Same thing which V is nothing but is equals to constant. If you want, you can write this also or this. Anything is fine. అర్థమైందా? Hello? Nothing but molarity, ra. N by V, nothing but molarity. Shall I move? So active mass. So AA plus BB gives rise to products. According to law of mass action, I told you rate of the reaction. Rate is directly proportional to A power A and B power B. Right, ra? It is AB molar concentrations. The proportionality constant, if you are removing the proportionality constant is A is equals to A power A and B power B. K is what? Rate constant. K is called rate constant. Already we wrote this. If you want, you can write it down. concentration of A and concentration of B, molar concentrations. So rate of reaction is directly proportional to same law, the proportionality constant. If you are removing the proportionality constant, we are removing the proportionality constant, so we are putting 1K. Okay, now? This is for forward reaction, these are the reactants, yes or no? For backward reactions, these are the reactants. So rate of forward reaction this now, and rate of for backward reaction this. So we know at equilibrium, rate of forward as well as rate of backward are equal, right? Yes or no? Hello? Right for both? What is Kf and what is Kb now? So Kf and Kb. For forward, Kf means forward reaction, Kb means backward. In case of backward means these are the reactants, these are products, yes or no? Hello? Hello? అర్థమవుతుందా ఏం చెప్తున్నాను? హలో? కీర్తన అర్థమవుతుందా? అంతేనా? Completed? Hello? Right. At equilibrium, what happens? Rate of forward reaction is equals to rate of backward reaction. So Kf so just both are we are equating. So Kf by Kb is equals to this. Kf by Kb nothing but Kc. Kc is equilibrium constant. Write it down. At equilibrium, rate of forward reaction is equals to rate of backward reaction. Rate of forward reaction is equals to rate of backward reaction. సో ఏం లేదురా, అది ఈక్వేషన్ని కిందికి తీసుకొస్తే, దీన్ని ఇక్కడ తీసుకొస్తే కేఎఫ్ బై కేబీ ఈజ్ ఈక్వల్స్ టు, ఇది కేబీ కిందికి వస్తుంది, ఇది ఇక్కడికి వెళ్తుంది. అర్థమైందా? కేఎఫ్ బై కేఎఫ్సి, కేబీ ఈజ్ ఈక్వల్స్ టు కేసీ. సో టోటల్ మనం ఈక్విలిబ్రియంలో కేసీ కేపీ రిలేషన్షిప్ గురించి మాట్లాడతాం. Completed? Once it's done, please let me know. Right. So here is equilibrium constants are, I told you, 3 types. Equilibrium constant in terms of concentration, when we are taking the concentration, we will say Kc. If we are taking, if any gas is there, if any one gas is there, we'll take partial pressures, Kp. So here is Kx equilibrium constant in terms of mole fraction, but generally we are not using much this. Okay, Kc and Kp are the temperature dependent only. So write it down, Kc, Kp, and we'll discuss the derivation of Kc, Kp relationship. Kc means what? Equilibrium constant in terms of concentration. Concentration means mole per liter. We'll take in this case equilibrium constant in terms of partial pressure. Then hello. So and this is important. Kc, Kp are temperature dependent. 5-star point పెట్టుకొని రాసేసుకో. 5-star. 5-star. Why I am telling the 5-star? I let you know. Kc and Kp are temperature dependent only. Temperature dependent. Done. So equilibrium constant Kc. Kc is the equilibrium constant of active masses are expressed in the concentration. So Kc is equals to, I already told you, concentration of, right, products concentration by reactants concentration. Right, for example, N2 plus 3H2 gives rise to 2NH3. 2NH3. Okay. How can we write? Kc is equals to concentration of products, NH3 concentration, whatever the coefficients are there, we'll write up, and concentration of N2 H2 power 3 nano. Got it? For example, AA plus BB gives rise to CC plus DD. How can we write Kc? Concentration C power C. First we have to write the products now. C power D by A power A into B power B. Okay. Hello. Right, done. Done. Same thing. It is already I told you Kf and Kb depends on only on temperature. Example, CaCO3 CaO plus CO2. So in this case, Kc is equals to only CO2E2, right? So pure solids is taken as unity. So if the pure solids are there, so we can't take in the concentration case. Okay. Write it down, this also. So pure liquid, this is an aqueous case, aqueous case. No. Pure solid and liquid cases also we won't take. Solid and liquid case concentration is equals to unity, right? So here I'll give you one more example, so don't confuse. So this Kp and all I'll discuss tomorrow. I'll discuss Kp and relationship between Kp and Kc and Gibbs free energy relation. Uh, this one or this one. Maximum tomorrow I'll try to finish this chemical equilibrium. We'll move into the ionic equilibrium. But majorly the numericals part also they are asking. And some cases, whatever the equilibrium characteristics of equilibrium, 7 equilibrium characteristics which I gave you, right? So from that they are asking the question. So each and every point is important. So don't ignore. In earlier cases only we were studying only important points, but so they are not asking important questions. They are asking anything. They are asking statement 1, statement 2, which is following the right or wrong, doesn't matter. And equilibrium chapter, chemical and ionic equilibrium, one of the crucial part for JEE as well as NEET. Okay, na? So even I'll give you a number of numericals. Previous year questions also will do in the next class. Right now. Are you gonna complete it? Completed, sir. Right.